Question 11. Quite late in the paper for our partial fractions question, but here we go. We need 1 plus 11x minus 6x squared. That needs to be equal to, well, the a needs both of those bits next to it. The b just needs the other one, that one down there, the 1 minus 2x, and the c needs the x minus 3 there. So what should we do? We'll do x equals 3 first, shall we? When you put x equals 3 in there, you get minus 20 here, that's 0, and we're getting minus 5 b's there, so that makes b equal to 4. Another value to put in is x is equal to a half. That makes this bit 0 and this bit 0. So we've got 2.5 c's, and putting a half into there, that makes 5. Sorry, minus 2.5 c's there, that makes 5. So I've got c is equal to minus 2. Now to find out what a is, some people might throw in x equals 0, but I usually just count the x squareds. In that I've got minus 6x squareds here. There aren't any x squareds there, there aren't any x squareds here. The only x squareds we're getting are from here. So there's minus 2a of them. So that makes a is equal to 3. So we've got a 3 here, we've got a 4 there, and a minus 2 there. Part B, I mean, this is interesting in that what you normally have to do is you usually have to integrate this thing. We're being asked to find out when it's a decreasing function. So that implies that we're actually going to differentiate it. We're differentiating 3. Now, let's write this in a way that we're going to be able to differentiate it. 4 lots of x minus 3 to the power of minus 1, and then minus 2 lots of 1 minus 2x to the power of minus 1. Differentiating. That just disappears, and here, well, the bracket stays the same, the power goes down by 1, I've got 4 times by the power times by the number of x's there, so I've got a minus 4 coming out here. Let's do the same here. So the bracket stays the same. The power goes down by 1. Now what's coming outside here? I've got to times the minus 2 by the minus 1 by the minus 2. So I've actually got, there's 3 minuses there actually, aren't there? So it's minus 4 here. So that's what it differentiates to. Let's rewrite that. And we've got a minus, so both of these things are negative actually, aren't they? We've got minus 4 over this and minus 4 over that. Now there's some words. Why is this always a decreasing function? Well look, x plus 3 squared is always greater than 0. Can't be either or equal to 0 because x was greater than 3. 1 minus 2x squared, that is always going to be greater than 0, or greater than or equal to 0, that one there actually. So that means if this is always positive, then this bit here is always negative. This bit here is always negative, and so therefore always negative. Therefore always decreasing. That's what that scribble down there says. Always decreasing. Just had a little think. No, this is just always greater than 0, isn't it? There's no or equal to there. X had to be greater than 3, and so 1 minus 2x is going to be minus 5 or minus 4 or minus 5 or minus 6 or minus 7. It's always going to get bigger and bigger, more and more negative. So squared, it will be greater than 0, not greater than or equal to.